Here is something that should genuinely bother you. The universe is 13.8 billion years old. Earth is only around 4.5 billion years old. Intelligent life had billions of years to get a head start on us, and yet every direction we point our instruments, every frequency we scan, every sky survey we run, nothing answers back. Not one civilization, not one megastructure, not one stray signal. Scientists call this the Great Silence. For decades they assumed it meant the universe was mostly empty. Tonight we're going to look at the explanation they don't like talking about, the one that says the universe isn't empty at all, that the silence is a strategy, and every civilization still alive in the Milky Way is using it to avoid being found. If you're new here, hit like and subscribe, settle in, get comfortable, because tonight we follow one question: where is everybody? From a lunch table in New Mexico in 1950, through decades of instruments that kept getting better and kept hearing nothing, to the only explanation left standing that nobody in mainstream science particularly wants to be true. Now, let's slowly ease into this. Part 1. The sky is too quiet. Right now, above you, there is a silence so complete and so enormous that the human mind was not built to hold it. Not the silence of an empty room, or a forest at 3 a.m, or the pause between heartbeats when you get news you weren't ready for. This is a different category of silence entirely. This is the silence of 100,000 galaxies, each one containing hundreds of billions of stars, each one searched with instruments so sensitive they could detect the heat signature of a city from across the cosmic neighborhood, and across all of that searching, across all of those stars and galaxies and decades of listening, we have heard nothing. Not a whisper, not a pattern, not a single deliberate signal that we can point to and say, that came from somewhere that thinks. And here is the thing that should stop you cold. That silence is not what the math predicted. When astronomers in the 1950s and 60s started doing the calculations seriously, they expected noise. They expected a galaxy humming with the electromagnetic byproduct of technological civilizations. Radio waves, laser pulses, waste heat from megastructures, the industrial signatures of species that had been building things for millions of years longer than we have. The universe is 13.8 billion years old. Our sun is 4.6 billion years old. That means there were stars forming, and potentially planets forming around them, and potentially life beginning on those planets, a full 9 billion years before our solar system even existed. 9 billion years is so much time that if you compress the entire history of the universe into a single calendar year, our sun wouldn't ignite until mid-September. Whatever is out there has had a head start on us that makes our entire civilization look like something that happened in the last few seconds of December 31st, and we hear nothing. The instrument we use to think about this problem is called the Drake equation, named for astronomer Frank Drake, who sketched it on a blackboard in 1961 at the first formal SETI conference in Greenbank, West Virginia. The equation is not really a calculation so much as it is a framework for organizing ignorance. It asks you to multiply together a series of estimates, the rate of star formation, the fraction of stars with planets, the fraction of those planets that could support life, the fraction where life actually emerges, the fraction where life becomes intelligent, the fraction where intelligence becomes communicative, and finally the average lifespan of a technological civilization. Multiply all of those together and you get a number, the estimated number of communicating civilizations in the Milky Way right now. The problem is that the last variable, the lifespan variable, the one astronomers label with the letter L, swamps everything else. If civilizations typically last 1 million years, the galaxy should be teeming. If they typically last 100 years, about as long as radio technology has existed on Earth, the galaxy might feel very empty even if life is everywhere. L is the variable we know least about, and it is also the variable that matters most. It is the unknown at the center of the entire question. But here is what the optimistic end of the Drake equation predicts. under reasonable assumptions that most astrobiologists would not dismiss as crazy, there should be somewhere between 1,000 and 1,000,000 technological civilizations in the Milky Way alone. Our galaxy contains somewhere between 200 billion and 400 billion stars. Even if intelligent life is extraordinarily rare, arising only once in every 100 million star systems, that still gives us 2,000 to 4,000 civilizations in our galaxy. And if the universe contains 2 trillion galaxies, as the best current estimates suggest, the total number of technological civilizations that have ever existed across all of observable space is a number so large it would take you longer to read it aloud than the Earth has been a planet. We searched, we listened, we looked in every direction and across every frequency we could manage, and the sky was acoustically dead. This is what astronomers call the Fermi Paradox, though we will get to Fermi properly in a moment. The collision between what the math predicts and what the instruments detect. The gap between the expected universe and the observed one. Some scientists call it the techno-signature gap, which sounds clinical and tidy, but what it actually is, when you sit with it at night, is one of the most disturbing facts in the entire history of science. Because there are really only 2 possible explanations. Either the math is wrong by many orders of magnitude, meaning intelligent life is so extraordinarily, almost impossibly rare that we are effectively alone in the observable universe, or the math is right and intelligent life is common, in which case something is happening to all of it that prevents us from seeing it. Either we are the miracle exception, the one candle lit in an otherwise dark room, or we are surrounded by something we cannot perceive. The first option should make you feel lonely in a way that goes bone deep. The second option should make you feel something considerably worse. For most of the history of SETI, the field has operated under a kind of cautious optimism. The instruments aren't sensitive enough yet. We've only searched a tiny fraction of the sky. The signals might be in a frequency range we haven't checked. Give it time, give it funding, give it better telescopes and more computational power, and eventually something will come through. That is a reasonable position. It is also the comfortable one. Tonight we're going to spend some time with the uncomfortable one, because there is an explanation for the great silence that does not require the universe to be empty. It does not require life to be impossibly rare or intelligence to be a cosmic accident. It requires something far stranger, and in some ways far more consistent with what we actually know about how intelligence operates. It requires that the silence is not a puzzle to be solved, but a strategy being followed, and that every civilization still alive in this galaxy has already worked out, through whatever process of painful experience or cold calculation, exactly why they must never speak. Not why they cannot, why they must not. The sky is not empty, the sky is listening. And the question that will carry us through everything that follows is this. If the forest is this quiet, if a universe full of minds has gone this completely, this consistently, this universally dark, who turned out the lights, and what exactly are they listening for? Part 2, Fermi's question was slightly wrong. The story that gets told about Enrico Fermi is almost too perfect, which probably means it has been polished by repetition into something smoother than the original. The year was 1950. The place was Los Alamos National Laboratory in New Mexico, a facility that had recently been involved in building the most destructive weapons in human history, which gives the conversation a certain historical weight in retrospect. Fermi was at lunch with several colleagues, and the conversation had drifted to a New Yorker cartoon that was circulating at the time, a joke about flying saucers and missing garbage cans. Someone made a comment about extraterrestrial visitors, and Fermi, who had a reputation for turning casual observations into profound physics problems, apparently looked up from his food and said something to the effect of, "Where is everybody?" It sounds like a simple question. It was not. What Fermi was pointing at, intuitively and quickly in the way that great physicists often do, was a contradiction between time and space. Here is the logic. The Milky Way is roughly 100,000 light-years across. A civilization capable of building self-replicating space probes, machines that travel to a new star system, harvest local resources, and build copies of themselves to send to the next star, could theoretically colonize the entire galaxy in somewhere between 5 million and 50 million years. That sounds like a lot of time. It is not a lot of time. The galaxy is 10 billion years old. 5 million years is 1/20th of 1% of the galaxy's age. In geological terms, it is nothing. In cosmological terms, it is a rounding error. So if even one civilization arose anywhere in the Milky Way even 100 million years before we did, and given the age of the galaxy, there have been plenty of opportunities, and if that civilization developed self-replicating probes, or even just slow generational ships, the math says they should have filled every corner of the galaxy long before our sun formed. We should have found their artifacts on Mars. We should have detected their engineering projects reshaping nearby stars. We should be living inside a galaxy that bears the unmistakable fingerprints of older intelligence, the way a forest bears the fingerprints of every creature that has ever lived in it. And we find nothing of the kind. The mathematician John von Neumann had already sketched out the logic of self-replicating machines in the 1940s, and his work was later extended specifically to the question of interstellar colonization by physicist Frank Tipler, whose name is attached to the aggressive version of this argument. Tipler's position was essentially that if even one civilization in the history of the galaxy had sent out self-replicating probes, we would know about it by now, because those probes would be everywhere. The absence of evidence for such probes was, to Tipler, evidence for the absence of such civilizations. He drew a fairly stark conclusion from this. We are alone. But here is where Fermi's question, brilliant as it was, contains a subtle assumption worth examining. Fermi was asking where they are. The implicit assumption in that question is that we would be able to see them if they were here. That intelligence in the universe expresses itself in ways that are detectable to other intelligences. That a civilization sufficiently advanced to colonize a galaxy would leave behind a galaxy-sized mess. Waste heat from megastructures, electromagnetic signals bleeding into space, the industrial signatures of a species that does not worry about being noticed because it has already won every conceivable conflict it might face. But what if that assumption is wrong? What if the question is not where they are, but why we would expect them to be visible in the first place? What if visibility is not a natural byproduct of intelligence and technology, but rather a phase that civilizations pass through briefly, the way a fire burns brightly for a moment before settling into something slower and harder to see? And what if, and this is where we start to move toward the idea that is going to follow us for the rest of this conversation, what if visibility is not just a phase but a mistake? What if civilizations that broadcast their existence into the cosmos do not tend to persist, and the ones that survive are precisely the ones that have learned, through whatever means, to go dark? That would explain the silence not as emptiness but as outcome, not as a puzzle but as a pattern. And it would mean that Fermi's question, precise and beautiful as it was asking the wrong thing. The right question is not where is everybody. The right question is why is nobody broadcasting? Because those are not the same question, not even close. The difference between those two questions is the difference between a universe that is empty and a universe that is full but frightened. And it is that difference, that terrifying gap between those two possibilities, that we're going to spend the rest of tonight exploring. Part 3. The weight of negative evidence. There is a particular kind of frustration that scientists rarely talk about publicly, because it does not look like progress, and science is supposed to be about progress. It is the frustration of improving your instruments and hearing more nothing. In 1960, a young astronomer named Frank Drake, the same Frank Drake who would go on to write the equation, pointed an 85-foot radio telescope at two nearby sun-like stars from the National Radio Astronomy Observatory in Greenbank, West Virginia, and listened. The project was called Ozma, named for the Queen of the Land of Oz, which was a nice touch, a faraway place populated by strange and wonderful beings, reachable only if you knew the right path. Drake listened at the 21-centimeter hydrogen line, the frequency that hydrogen atoms naturally emit when electrons change energy states. The logic was that any technologically sophisticated civilization would know about this frequency, since hydrogen is the most abundant element in the universe and might choose it as a kind of universal broadcast channel, the cosmic equivalent of a common frequency everyone knows to tune to in an emergency. He heard nothing. 2 stars, months of observation, nothing. That was 65 years ago. In the decades since, SETI researchers have searched with increasingly powerful instruments, increasingly sophisticated signal processing, and increasingly broad coverage of both the radio spectrum and the sky. Project Phoenix scanned nearly 1,000 nearby stars. The Allen Telescope Array expanded the search. Breakthrough. Listen, funded by billionaire Yuri Milner starting in 2015, brought the most comprehensive and well-funded search in SETI history, scanning hundreds of thousands of stars across a range of frequencies and adding optical SETI to look for laser pulses as well as radio waves. The results have been consistent. Remarkably, almost defiantly consistent. Nothing. Now, before the inevitable objection, we have not searched everywhere, we have not listened long enough, we have not covered enough frequencies. Let me be clear that this is absolutely true, and every honest SETI researcher acknowledges it readily. We have searched a tiny fraction of the total available parameter space. If the cosmic haystack is the size of the Earth's oceans, we have searched something like a hot tub's worth. The absence of a detection does not prove absence of signal. But here is the thing. Every time we improve our instruments, we rule out more possibilities. Every time Breakthrough listens, scans another 100,000 stars and finds nothing, the range of places a signal could be hiding gets smaller. The silence is not just continuing, it is becoming statistically more significant with every passing year. Scientists call this constraint tightening, and it is a slow, grinding, uncomfortable process that the public rarely pays attention to because no one holds a press conference to announce that they have not found anything. And the silence is not just in the radio frequencies. In 2015, a team of researchers at Penn State published results from the Glimpsing Heat emissions from Annihilating Civilizations project. Yes, the acronym is GHAT, which used data from NASA's WISE infrared space telescope to search for what are called Dyson spheres. A Dyson sphere, first proposed by physicist Freeman Dyson in 1960, is a megastructure built by a sufficiently advanced civilization around its host star to capture essentially all of the star's energy output. The logic is straightforward. If you are a Kardashev Type II civilization, meaning a civilization that uses all the energy of its star, you have to do something with that energy, and according to thermodynamics, the waste heat has to go somewhere. It would show up as anomalous infrared radiation at a temperature around 300 Kelvin, which is the temperature at which the waste heat of a star-enclosing structure would radiate. The GHAT team searched over 100,000 galaxies. 100,000 galaxies, each containing hundreds of billions of stars, representing a collective sample of tens of trillions of star systems. Not a single confirmed Dyson sphere. Not one galaxy showing the infrared signature of a Kardashev Type III civilization, a civilization using the energy of an entire galaxy. Let that land for a moment. 100,000 galaxies. 0. Now you might say, maybe Dyson spheres are not how advanced civilizations harvest energy. Maybe there are other approaches. Maybe the physics of megastructures doesn't work out the way we think. All of that is possible. But the infrared search is important precisely because it is a physical constraint, not a technological one. You cannot use energy without producing waste heat. That is not a technological assumption, it is a thermodynamic law. And if civilizations are using energy at galactic scales, the scales we would expect from intelligent species with billions of years of head start on us, the waste heat has to be somewhere. The silence across multiple detection channels is what makes it statistically unsettling. It is not just that Radio SETI has found nothing. It is that Radio SETI has found nothing, and infrared surveys have found nothing, and optical SETI has found nothing, and our searches of nearby star systems for anomalous objects have found nothing. Every independent line of inquiry points to the same blank wall. Unless, and this is the possibility that refuses to leave the room, civilizations that survive long enough to become detectable also survive long enough to figure out that being detectable is dangerous, and they actively engineer themselves out of visibility, not because they are hiding from us specifically, because they are hiding from everything, because they have learned, perhaps at terrible cost, that a universe capable of producing intelligence is also a universe capable of eliminating it, and the two things are not unrelated. The silence across all channels might not be the silence of an empty room. It might be the silence of a very full room where everyone has agreed, for reasons they have not yet explained to us, to hold completely still. Part 4. The one signal that broke the pattern. On the night of August 15th, 1977, a radio telescope called the Big Ear at Ohio State University was doing what it did every night, slowly scanning the sky, recording the signal strength of incoming radio waves on a printout that researchers would review later. The telescope was not operated by a human being in real time. It was automated, methodical, patient in the way that machines are patient. Most nights the printout was a sequence of unremarkable numbers representing the background hiss of the universe. On that particular printout, a researcher named Jerry Eman found something different. The telescope had recorded an anomalous signal at exactly the 21 centimeter hydrogen line frequency, the same frequency Frank Drake had listened at 17 years earlier, the frequency that, if you were going to choose a universal broadcast channel, you would probably choose. The signal lasted 72 seconds, the exact duration that a legitimate extraterrestrial signal would last, given the rotation rate of the Earth and the fixed position of the antenna. It was narrowband, meaning it occupied an unusually small slice of the radio spectrum, the kind of tight focus that would be produced by a technological transmitter rather than a natural astrophysical process. It was strong, significantly stronger than background noise, in a pattern consistent with a signal source moving with the fixed stars. Jerry Eman circled the relevant numbers on the printout and wrote one word in the margin. Wow. That word has been the name of the signal ever since. The wow signal. In the decades following, astronomers have pointed virtually every major radio telescope capable of revisiting that patch of sky at that frequency and listened. The signal has never repeated. Not once in 48 years of follow-up observation across multiple telescopes on multiple continents. The most sophisticated attempts at redetection, including dedicated campaigns using the most sensitive instruments available, have heard nothing but background noise from that direction. There have been proposed explanations: a comet passing through the beam, terrestrial interference of some exotic kind, an unusual astrophysical source we have not identified. Each of these explanations has problems. The comet hypothesis, proposed in 2017, was criticized by multiple researchers who pointed out that comets do not naturally emit narrowband radio signals at the hydrogen line frequency. The interference explanations struggle to account for the precise 72-second duration and the frequency match. The unknown astrophysical source remains unknown and unidentified. But there is a third category of interpretation that no one in mainstream science will say out loud at a conference, but that sits quietly at the edge of the discussion like a figure in a doorway. What if it was real? What if it was a deliberate transmission? And what if the reason it never repeated is not because it was a fluke, but because whatever sent it went immediately, deliberately, and permanently silent? Under the logic we are building toward tonight, a single transmission followed by instant silence is not a failure of the signal. It is the signal behaving exactly as a civilization operating under the strategic logic of the dark forest would predict. You transmit. Someone, somewhere, receives. And then you realize, or perhaps you already knew, that transmitting was an error, and you do everything in your power to ensure it never happens again. The wow signal, under this interpretation, is not an anomaly. It is a data point. It is the sound of a civilization making a mistake and then correcting it. And the silence that followed is not the absence of an answer. It is the answer. What that answer means, and why any civilization capable of deliberate transmission would choose permanent silence over continued communication is what we need to understand. Because the logic that produces that choice is colder and more coherent than most people are ready for. Part 5. The menu of explanations and why none satisfy. When a problem sits unresolved for long enough, it accumulates explanations the way a ship accumulates barnacles. Each one attaches itself plausibly, adds some drag, and fails to actually solve the underlying problem. The Fermi Paradox has more proposed solutions than perhaps any other open question in science, and the fact that none of them has achieved consensus after more than 7 decades of serious discussion is itself a kind of evidence that the problem is harder than any single elegant answer can accommodate. Let us walk through the major ones, because understanding why each of them falls short is necessary for understanding why the one we are moving toward is different. The rare earth hypothesis says that complex life is extraordinarily uncommon, not because the laws of physics do not permit it, but because the specific combination of circumstances required to produce it is vanishingly unlikely. You need a star of the right size and stability. You need a planet in the habitable zone. You need a large moon to stabilize your axial tilt. You need a giant planet like Jupiter in the outer system to act as a gravitational shield, deflecting comets and asteroids that would otherwise sterilize your biosphere every few million years. You need plate tectonics to recycle carbon and regulate temperature over geological timescales. The argument, made most forcefully by paleontologist Peter Ward and astronomer Donald Brownlee in their 2000 book of the same name, is that while microbial life might be common, complex multicellular life requires so many simultaneous conditions that it might be extraordinarily rare, perhaps uniquely so. This is a serious argument. But it does not fully solve the paradox. Even granting all of the restrictive conditions Ward and Brownlee propose, the universe contains so many stars, 2 trillion galaxies, each with hundreds of billions of stars, that even 1 in a trillion odds leaves you with millions of complex civilizations. Rare earth shrinks the number, but does not eliminate the fundamental contradiction. The Great Filter is a concept introduced by economist Robin Hanson in 1998. The idea is that somewhere along the path from simple chemistry to galaxy-colonizing civilization, there is a step so difficult that almost nothing makes it through: a filter. The terrifying version of this idea is that the filter lies ahead of us, that it is something we have not yet encountered but will, and that it is the reason we see no advanced civilizations. Maybe it is the invention of a self-replicating technology that inevitably escapes control. Maybe it is the development of weapons capable of sterilizing a planet. Maybe it is the simple thermodynamic unsustainability of an industrial civilization on a finite world. If the Great Filter is ahead of us, then our apparent uniqueness, our failure to find peers, is not a celebration. It is a warning. The more hopeful version says the filter is behind us. Maybe the transition from prokaryote to eukaryote, or from single-celled life to multicellular life, or from primate to language-using primate, is the step so difficult that we're effectively the only thing that made it through in our neighborhood. If that's the case, we are the miracle, and the cosmos is ours to fill. Both versions explain the silence. Neither tells us what to do with it in any practical sense. The estivation hypothesis, proposed by researchers Anders Sandberg, Stuart Armstrong and Milan Kirkovic in 2017, suggests something even stranger. The argument starts from information theory and thermodynamics. Computation, thinking, produces waste heat. Waste heat limits computation efficiency. But as the universe expands and cools, the temperature of the cosmic microwave background decreases, and lower background temperatures allow for more efficient computation. A civilization that wants to maximize the total amount of thinking it can ever do would therefore be better served by waiting, estivating, like an animal entering a state of low metabolism during a hot season, until the universe cools enough that their computational reserves can be used with maximum efficiency. Under this model, advanced civilizations are not absent. They are dormant, waiting for a universe cold enough to think their great thoughts in. It is elegant. It is also entirely unfalsifiable, which is both its philosophical weakness and, in a strange way, part of what makes it feel plausible. We cannot disprove it, and it explains the silence without requiring catastrophe. The simulation hypothesis suggests that the universe we observe is itself a computational simulation, and that the apparent absence of intelligence reflects a deliberate design choice by whoever is running the simulation. This explains everything and predicts nothing, which makes it philosophically interesting and scientifically inert. Here is what all of these explanations share. They each treat the silence as something that happens to civilizations, a filter they cannot pass, a physical constraint they optimize around, an illusion created by our computational substrate. They are passive models. The universe produces civilizations, and civilizations encounter some fate that makes them invisible. There is only one major explanation that treats silence as behavior, as choice, as something that intelligent agents actively decide for reasons rooted in the same logic that governs every other strategic decision made by entities that want to survive. That explanation says the silence is not evidence of what has happened to civilizations. It is evidence of what civilizations have learned. And what they have learned, what every surviving intelligence in this galaxy has apparently worked out, is a conclusion so stark and so logical that once you follow the reasoning all the way to its end, you may find yourself questioning whether we should ever have spoken at all. We are almost ready to meet that idea. But first, we need to understand where it came from, and why the person who first articulated it scientifically was largely ignored for a decade before a science fiction author turned it into something the world could not forget. Part 6. The Forgotten Warning. In 1983, an astronomer and science fiction author named David Brin published a paper in the Quarterly Journal of the Royal Astronomical Society. The paper was titled The Great Silence, the controversy concerning extraterrestrial intelligent life. It was a serious, peer-reviewed piece of scientific literature, published in one of the most respected journals in the field, and it proposed something that the SETI community was not yet ready to engage with seriously. Brin surveyed the existing explanations for the Fermi Paradox. He was one of the first to do so comprehensively, and among the solutions he examined was one that had received almost no formal attention: the possibility that the universe contains self-replicating systems, possibly including artificial intelligence or robotic probes that are actively hostile to newly emerging technological civilizations, and that the silence we observe is partly a consequence of this hostility. He did not claim this was definitely happening. He was a scientist, not a doomsayer. But he took the possibility seriously in a way that mainstream SETI discourse had been reluctant to do. The prevailing mood in the SETI community in the 1980s was optimistic. The feeling was that any civilization capable of interstellar communication would also be wise enough, old enough, and secure enough to be friendly. The Drake-Sagan view of the cosmos was essentially a hopeful one. Intelligence was precious. Rare civilizations would recognize each other as kin, and first contact, if and when it came, would represent the beginning of something wonderful. Brin was not so sure. He pointed out that this assumption, that advanced civilizations are necessarily benevolent, was itself an assumption, not a deduction. We had exactly one data point for what intelligent technological civilizations do: ourselves. And our own history did not support the conclusion that power and benevolence reliably go together. Throughout human history, encounters between technologically unequal civilizations had not gone well for the less advanced party. Brin did not think this necessarily meant extraterrestrial civilizations would behave like European colonizers, but he thought it was naive to assume they would not, and that the question deserved serious consideration. More importantly, Brin raised what he called the deadly probes concept. If a sufficiently paranoid civilization, not necessarily evil, just cautious, decided that the emergence of new technological species represented a potential long-term competitive threat, It might deploy self-replicating systems designed to identify and eliminate such species before they became capable of posing that threat. The probes would spread through the galaxy the same way benevolent von Neumann probes would spread. But instead of broadcasting greetings, they would be listening for the signatures of new civilizations and responding to what they found. Under this model, the silence has a selection pressure component. Civilizations that broadcast loudly do not persist long enough to be found by SETI researchers. The ones that learn to be quiet survive. Over millions of years, the survivors are the quiet ones, and what we observe, the silence, is the outcome of that selection. Brin's paper made relatively little splash at the time. The SETI community had a significant emotional investment in the optimistic view, and an argument that first contact might be catastrophic was not a popular one. The 1980s were also a period of intense public enthusiasm about the possibility of contacting alien civilizations, fueled by Carl Sagan's television series Cosmos, and the enormous cultural footprint of films like Close Encounters of the Third Kind and E.T. People wanted the aliens to be friendly. They did not particularly want to hear from a peer-reviewed astrophysics paper that the silence might be a warning. But Brin had planted a seed that would lie dormant for another 2 decades before a Chinese physicist and science fiction writer named Liu Cixin would water it into something extraordinary. And what Liu Cixin built from that seed is not just a story, it is a formal argument, a logical structure, a way of looking at the cosmos that, once you have internalized it, makes the silence not just plausible, but inevitable, and makes our own behavior, our decades of broadcasting and searching, look less like a heroic quest and more like a very dangerous mistake. Part 7. The forest gets a name. There is a particular kind of idea that works on you slowly. You encounter it, you find it interesting, you move on with your life, and then a week later you are standing in a grocery store or looking out a window, and the idea comes back to you, slightly larger than before, carrying implications it did not seem to carry when you first met it, and then it comes back again and again, until one day you realize that you have not stopped thinking about it, that it has rearranged some furniture in your mind that you did not know was movable. Liu Cixin's dark forest theory is that kind of idea. Liu Cixin is a Chinese science fiction author, trained as an engineer, who worked for most of his career at a power plant in Shanxi province, while writing some of the most ambitious and philosophically rigorous science fiction of the last century. His novel, The Dark Forest, published in Chinese in 2008 and translated into English in 2015, is the second volume of his three-body problem trilogy. The book sold millions of copies worldwide and introduced a general audience to a formal logical framework for understanding the Fermi Paradox that no scientist had previously articulated with quite such terrifying clarity. The central metaphor is this. Imagine the universe as a dark forest. In this forest, there are hunters, many hunters. Each hunter carries a weapon. Each hunter is extremely quiet, moving through the trees without speaking, without making noise, without revealing their position. Not because they are cautious by nature, not because they are afraid of the dark, but because every hunter in this forest knows two things with absolute certainty. First, that survival is the primary goal of every living thing, and second, that resources, space, matter, energy are limited, and competition for them is inevitable. Now here is the critical insight that transforms the metaphor into a logical argument. In this forest, you can never be certain of another hunter's intentions. You cannot read their mind. You cannot verify their claims. You cannot watch them long enough to establish a pattern of trustworthy behavior, because the forest is so large and communication is so slow that by the time you have any meaningful data about a particular hunter, your own situation may have changed beyond recognition. Under these conditions of radical uncertainty and radical stakes, where a wrong guess about trust does not cost you money or status but your life, what is the rational strategy? The rational strategy is silence. And if you detect another hunter, The rational strategy is to eliminate the threat before it can eliminate you, not out of malice, but out of the cold mathematics of survival under uncertainty. Liu Cixin formalizes this through what he calls 2 axioms and 2 theorems. The first axiom is that survival is the primary need of civilization. The second axiom is that civilization continually grows and expands, but the total matter and energy in the universe remains constant. From these 2 premises, a logical chain follows. Because resources are finite, competition is inevitable. Because competition is inevitable, any civilization is a potential threat to any other. Because you cannot verify intent across interstellar distances, you cannot trust any civilization you encounter. Because you cannot trust and cannot verify, the safest response to detecting another civilization is preemptive elimination, not because they are your enemy, but because they might become one, and by the time you know for certain, it may be too late. This is not a story about evil. It is a story about logic under uncertainty. What Liu Cixin calls cosmic paranoia equilibrium, my term, not his, but the concept is his, is a stable state in which all surviving civilizations have independently arrived at the same conclusion. The only safe thing to do is stay hidden, and any civilization that reveals its existence has either not yet understood the rules of the forest, or has already decided to take a catastrophic gamble. The Great Silence, under the Dark Forest framework, is not a mystery. It is the expected outcome. It is what you would predict if you took the 2 axioms seriously and followed the logic wherever it leads. The universe is not empty. The universe is full of hunters who have all independently reached the same conclusion about the cost of being heard. And we have been broadcasting. For decades we have been broadcasting. Radio waves, television signals, military radar, deliberate SETI transmissions. We have been lighting a fire in the middle of the dark forest and wondering why no one has come to warm themselves by it. The answer may be that something has noticed the fire, and it is not coming to warm itself. Part 8. The game theory that locks it in. The dark forest argument could be dismissed as science fiction speculation, vivid, interesting, but ultimately just a story, except for the fact that its underlying logic is not derived from narrative intuition. It is derived from a body of rigorous formal reasoning that was developed entirely independently of any thinking about extraterrestrial civilizations, by mathematicians and economists working on the entirely earthly problem of how rational agents behave when they cannot trust each other. The field is called game theory, and its foundations were laid by a man named John von Neumann, the same von Neumann whose self-replicating probes we discussed earlier, which is a coincidence that feels almost too neat, in a book called Theory of Games and Economic Behavior, co-authored with economist Oscar Morgenstern and published in 1944. Von Neumann's insight was that the outcome of any interaction between rational agents depends not just on what each agent does, but on what each agent predicts the other will do. The interesting cases, the cases that matter, are the ones where the best outcome for both parties requires cooperation, but where defection by either party, if the other cooperates, produces a better individual outcome. These situations are called prisoners' dilemmas, and they appear everywhere. In arms races, in trade negotiations, in any situation where trust is both valuable and unverifiable. Thomas Schelling, who won the Nobel Prize in Economics in 2005, extended this framework to situations with asymmetric stakes, situations where the cost of being wrong about trust is catastrophically different from the cost of being wrong about aggression. He developed the concept of credible commitment, which is the idea that cooperation requires not just the desire to cooperate, but the ability to credibly signal that desire in a way that cannot be faked and does not require trust in the other party's goodwill. Now apply this framework to interstellar civilizations. You detect a signal. You do not know the source's intentions. You cannot communicate with them in real time. At interstellar distances, a message takes years, decades, or centuries to arrive, and a response takes equally long. You cannot watch their behavior over multiple iterations to establish a reputation for trustworthiness, because the timescales involved make iterative trust building effectively impossible. you cannot make a credible commitment that they can verify, because any signal you send can be false, and any action you take in response to their signal is operating on information that is years out of date by the time you can act on it. In this environment, game theorists would tell you cooperation is extremely difficult to sustain. The prisoner's dilemma, when played once with no repeat interaction and no ability to communicate intent credibly, tends to resolve toward defection. Not because the players are evil, because defection is the dominant strategy when you cannot verify the other player's strategy. And in the interstellar version of this game, defection does not mean cheating on a trade deal, it means preemptive elimination. Because the stakes, the survival of your civilization, are too high to risk on a bet about the goodwill of an unknown. The asymmetric risk matrix looks like this. If you detect a civilization and it is hostile and you eliminate it preemptively, you survive. If it is friendly and you eliminate it preemptively, you have committed a terrible act, but you survive. If you detect a civilization and it is hostile and you do nothing, or try to establish friendly contact, you risk elimination. If it is friendly and you do nothing, you have missed an opportunity for cooperation, but you survive. 3 out of 4 outcomes favour preemptive action or at minimum silence. Only one outcome, the case where the other civilization is friendly and you establish contact, produces the benefit of cooperation, and you cannot know in advance which case you are in. You can never know. The communication delays, the technological unpredictability, the impossibility of verifying intent across light years, all of these factors ensure that uncertainty is permanent. The Nash equilibrium, the stable state from which no rational player has an incentive to unilaterally deviate, is silence. Every civilization stays quiet. Every civilization eliminates evidence of detection when possible. Every civilization that deviates from this equilibrium by broadcasting is gambling its existence on an assumption it cannot verify. The silence we observe is not the absence of intelligence. It is the presence of rational agents who have all independently solved the same game theory problem and arrived at the same answer. And the fact that we are sitting here, broadcasting radio waves and talking about finding friends in the cosmos, suggests that we are either the galaxy's most naive players, or we have simply not yet understood the rules of the game we are already in. Part 9. Chains of Suspicion. There is a thought experiment worth sitting with for a moment. Imagine 2 civilizations. Call them Civilization A and Civilization B. They are separated by 400 light-years, close as cosmic distances go, but far enough that a message sent from A today will not reach B until the year 2425. Civilization A detects what appears to be a technological signal from Civilization B's direction. They deliberate, and they decide to respond warmly. They compose a message expressing peaceful intentions, curiosity, a desire for mutual exchange of knowledge. They beam it in the direction of Civilization B. Then they wait. 400 years pass. Civilization A receives a response from Civilization B. It is also warm, also peaceful, also curious. The 2 civilizations begin a slow, century-long exchange of information. Both seem to be learning from each other. Both seem to be benefiting. But here is what the exchange cannot tell. Civilization A about Civilization B. What Civilization B was like 400 years ago when it sent that first response, or what it is like now, or what it will be like 400 years in the future when A's next message arrives. A civilization that is friendly, cooperative and trustworthy today might be something entirely different in 4 centuries. It might have undergone political transformation. It might have developed technology that changes its strategic calculus. It might have been replaced entirely or partially by something that shares its name but not its values. Civilization A is making decisions based on a centuries-old snapshot of Civilization B, and Civilization B is making decisions based on a centuries-old snapshot of Civilization A. Neither one can update their model of the other in real time. Neither one can say, I know who you are right now, as of this moment, and I trust that knowledge. Philosopher Nick Bostrom calls something related to this the technologically mature civilization problem. The capabilities of a civilization change exponentially over time, especially during periods of rapid technological development. A civilization that is roughly at our level of technology, capable of radio communication but not interstellar travel, might be decades or centuries away from developing capabilities that completely transform its strategic position in the galaxy. The same is true of any civilization you might contact. By the time your friendly exchange has established any meaningful relationship, both parties may have changed beyond the point where the original relationship is meaningful. The lightspeed communication delay does not just slow down information exchange. It destroys the foundations on which trust is normally built. Trust in any context, between individuals, between nations, between species, is built on repeated interaction, on the ability to update your model of the other party based on new information, on the credibility of commitments backed by ongoing relationship. Remove all of those foundations and replace them with centuries-long delays and snapshot information, and what you have left is not a relationship. It is a guess. A very expensive, very dangerous, irreversible guess. The chain of suspicion that the dark forest logic produces is not irrational paranoia. It is the structural consequence of communication delay at cosmic scales. Even two civilizations that genuinely want to cooperate, genuinely mean each other no harm, genuinely wish for mutual flourishing, they cannot verify these things about each other across light years, and in the absence of verification, the rational choice is to treat uncertainty as risk, and risk of extinction as something to be avoided at all costs. The first contact is always asymmetric, always irreversible, and always conducted on the basis of information that is hopelessly out of date. There is no way to fix this. It is not an engineering problem waiting for a better solution. It is a consequence of the speed of light and the size of the galaxy and the timescales over which civilizations change. And if you follow this logic all the way through, you arrive at a conclusion that reframes the entire history of SETI. Every message we have sent, every signal we have broadcast, every radar pulse and television transmission, and deliberate interstellar communication. Each one is an action taken under conditions of total ignorance about who might receive it, under the assumption that visibility is neutral or positive, without any ability to predict or control the response. We have been playing a game against opponents we cannot see, using rules we invented ourselves, without asking whether the opponents play by the same rules. The silence around us may be the most important communication we have ever received. The question is whether we are reading it correctly, and whether we have already run out of time to change our approach. Part 10. Why we don't see civilizations. Let us return to the infrared sky. When astronomers look at a galaxy through an infrared telescope, they are looking at heat. Every object in the universe that is warmer than absolute zero radiates heat in the form of infrared photons. Stars radiate enormous amounts of it. Planets radiate smaller amounts. The interstellar medium radiates a little. And if you had a galaxy full of Kardashev Type 2 or Type 3 civilizations using stellar or galactic levels of energy, you would expect to see anomalous infrared signatures that could not be explained by natural processes alone. The GHAT survey found none. Or rather, it found a small number of galaxies with slightly anomalous infrared signatures, but the degree of anomaly was tiny, far below what you would expect from a galaxy-spanning civilization, and each of the anomalous cases had natural explanations that could not be ruled out. But notice what this implies, if the dark forest theory is correct. A civilization that has internalized the logic of the dark forest would not build Dyson spheres. Or if it did, it would engineer them to minimize their detectability, not because Dyson spheres are technically difficult to build stealthily, because they probably are difficult to build stealthily, but because a civilization that has accepted the dark forest logic would treat energy use itself as a risk factor. Every unit of energy you consume above what is necessary for survival is a unit of waste heat you are radiating into space, advertising your presence to whatever is listening. The implication is stark. If the dark forest logic is correct, the selection pressure is not just towards silence in terms of deliberate radio transmissions, it is toward energetic minimalism, toward civilizations that optimize for stealth rather than expansion, toward hiding your computational infrastructure, minimizing your electromagnetic footprint, engineering your waste heat to match the background noise of natural processes. The galaxy could be densely populated with civilizations that have made exactly these choices, and we would never know. They would appear in every wavelength we can measure, exactly as they intended to appear, as nothing. This is the silent majority hypothesis. Not the silence of an empty galaxy, but the silence of a galaxy full of entities that have concluded that visibility is a form of vulnerability and have engineered themselves below the detection threshold of any instrument we are likely to build. They are not absent from our instruments because they are absent from the galaxy. They are absent from our instruments because making themselves detectable would be, from their perspective, an act of extraordinary recklessness. And here, somewhere in this section of our conversation, is where the emotional weight of the whole theory tends to land. Because if this is true, the galaxy is not the lonely place it appears to be. It is a crowded, complex, ancient environment full of intelligences that have learned, through whatever painful process of experience, that survival requires invisibility. That the universe is not a place of fellowship and discovery, and the slow accumulation of shared knowledge across species. It is a place of permanent, vigilant, solitary silence, maintained at enormous cost, for reasons that anyone who thinks about it carefully can derive from first principles. And we are here, in the middle of all of this, lighting fires. Part 11. The Métis Mistake. On November 16th, 1974, astronomers at the Arecibo Observatory in Puerto Rico aimed the world's then largest radio telescope at a globular cluster called Messier 13, located roughly 25,000 light-years from Earth, and broadcast a signal into space. The message, designed by Frank Drake and Carl Sagan with input from others, was a sequence of 1,679 binary digits that, when arranged in a 73 by 23 grid, depicted a visual representation of basic information about humanity: the structure of DNA, a diagram of a human figure, the solar system, the Arecibo telescope itself. It was meant as a demonstration of capability more than a serious attempt at communication. Drake himself acknowledged that the signal would not reach Messier 13 for another 25,000 years, by which time human civilization might not exist in any recognizable form. But it was also, in a deeper sense, a gesture, a statement of intent. Here we are, it said. Here is what we are. We are the kind of civilization that reaches out. The question that the Arecibo message raises, in the context of what we have been discussing, is whether reaching out is wise. Stephen Hawking, in several public statements before his death in 2018, argued that it was not. His reasoning tracked closely with the logic we have been developing. Hawking's concern was not that any specific civilization was definitely hostile, but that we cannot know that they are not, and that the asymmetry of the situation, where we are a young, technologically limited species, and any civilization capable of detecting and responding to our signals, is likely to be enormously more advanced, makes the gamble unreasonably dangerous. He compared it to Native Americans receiving Columbus's ships. The historical analogy for what happens when a technologically less advanced civilization makes contact with a more advanced one is not a reassuring one. David Brin has argued similarly, and has been one of the loudest voices in what is now called the METI debate, METI standing for Messaging Extraterrestrial Intelligence, the deliberate transmission of signals intended to be detected and understood by non-human civilizations. Brin's position is not that we should never attempt communication, but that we should think very carefully about what we are doing before we do it. That broadcasting into an unknown cosmos without any understanding of what might be listening is the kind of decision that, once made, cannot be unmade. On the other side of this debate, researchers like Seth Shostak at the SETI Institute have argued that the concern is somewhat moot, because Earth has already been broadcasting detectable signals for nearly a century. Our radio and television transmissions, our military radar pulses, the electromagnetic byproduct of our entire industrial civilization, all of this has been leaking into space at the speed of light since roughly the 1930s. The bubble of detectable Earth signals currently extends about 90 light-years in every direction from our Sun. Shostak's point is that the horse has already left the barn, and any civilization within 90 light-years that is capable of detecting us has probably already done so, making the METI debate at least partially academic. This is a fair point, but it cuts both ways. If we are already detectable, the question of whether to broadcast deliberately becomes less important than the question of what it means that we are already visible, already exposed, already inside the same risk structure that the dark forest theory describes. We did not choose to enter this situation. We were born into it by the same technological development that gives us the capacity to ask these questions in the first place. We're already in the forest, we're already carrying a torch, and somewhere in the darkness around us, something may already have noticed the light. Part 12. The detection problem. Here is a fact that deserves a moment of quiet attention. Right now, moving outward from Earth at the speed of light, approximately 300,000 kilometers per second, there is a sphere of human-generated electromagnetic radiation. The inner edge of this sphere, the oldest signals, the ones that have been travelling longest, is about 90 light-years from our Sun. The outer edge is adding new material every second, as every radio transmitter, every radar installation, every television broadcast tower, every wireless communication device on Earth leaks a little signal into space. Within that 90 light-year radius, any civilization with technology comparable to our own or better could, in principle, detect that we are here. Not necessarily decode our television programming. The signal weakens with distance according to the inverse square law, and at 90 light-years the signal-to-noise ratio is extremely low, but detect the anomalous electromagnetic signature of a technological civilization. Our planet does not look like a natural object anymore. It looks like a transmitter. The transit zone of the Earth, the ring of space from which a distant observer could watch Earth pass across the face of the Sun, contains several hundred nearby star systems from which Earth would be detectable as a transiting planet, and from which Earth's atmosphere could, in principle, be spectroscopically analysed for biosignatures. Oxygen, methane, the chemical disequilibrium of an atmosphere modified by life, all of these would be detectable by an instrument not much more advanced than what we already have. So we are visible, detectably visible, in multiple independent ways: radio signatures, spectroscopic biosignatures, transiting geometry. We are not hidden. We have never been hidden, at least not from anyone within a few hundred light-years with adequate instruments, and yet no one has responded. No one has knocked. No craft has appeared in our outer solar system. No signal has arrived at a frequency and with a structure that screams deliberately constructed. Nothing. Under the dark forest interpretation, this silence is itself informative. It does not mean no one has detected us. It means that the civilizations within detection range, if any exist, have, upon detecting us, chosen to maintain their silence, not to reach out, not to welcome us, not to warn us, to remain precisely as they have been, invisible, unresponsive, present only as an absence. We are not receiving silence from an empty universe. We may be receiving silence from entities that already know exactly where we are, and have decided, for reasons coherent with their own survival logic, to say nothing. Part 13. The one-shot civilizations. Consider a strange hypothesis that emerges naturally from combining the dark forest logic with the observational record of SETI. What if many civilizations, over the long history of the galaxy, have done exactly what we have done? What if they developed technology, became detectable, perhaps even transmitted deliberately, and then, through self-correction, through receiving a warning from somewhere, through the cold dawning of understanding that visibility was a mistake, went silent. Not because they were eliminated, not because they died, but because they understood finally what the rules of the game were, and they changed their behaviour accordingly. Under this model, the galaxy is not populated by civilizations that were always silent. It is populated by civilizations that were once noisy and learned to be quiet. The universe is full of what we might call one-shot civilizations, species that broadcast briefly, perhaps for decades or centuries, the way Earth has been broadcasting, and then realize their error and go dark. This would produce a very specific observational signature. The universe would be full of transient signals, brief, non-repeating anomalies, single detections with no follow-up, patterns that appear once in the data and then vanish, leaving no trace that would allow identification or localization of the source. Does that sound familiar? The WOW signal, one detection, 72 seconds, no repeat in 48 years of follow-up. There have been other candidate anomalies over the decades of SETI. The Lorimer burst in 2007 and the subsequent discovery of fast radio bursts have natural astrophysical explanations, but the early history of their detection bears a structural resemblance to the one-shot pattern. Various anomalous detections in SETI history have appeared once and not repeated. This does not mean any of these were deliberate transmissions from civilizations that then went silent. Most have natural explanations. But the hypothesis is structurally interesting because it makes a prediction. If civilizations go through a brief noisy phase and then become permanently quiet, you would expect to see occasional brief signals with no follow-up, scattered throughout the data, too rare and too transient to build a convincing statistical case around. You would expect to spend decades of searching and find mostly nothing, punctuated by occasional anomalies that resist explanation, which is, almost exactly, what the observational record of SETI shows. The galaxy may be an archive of vanished voices, not the voices of civilizations that died, but the voices of civilizations that learned to stop speaking. Each one broadcast for a while, a few decades perhaps, or a few centuries, while they were still young and optimistic and unafraid. And then they understood, and they went dark. And the silence that followed their understanding is the same silence we observe now, multiplied by however many civilizations have gone through the same process over the last few billion years. If this is true, we are at a particular moment in our own version of this story. We are in the noisy phase. We are the civilization that is still young enough, still optimistic enough, still unafraid enough to broadcast. And somewhere in the darkness, there may be older, quieter presences that remember being exactly where we are, and that are watching to see what we do next. Part 14. Competing Futures. At this point in our conversation, it is worth stepping back and looking at the three major frameworks for understanding the Fermi Paradox side by side, because they make very different predictions about what we should do. The Great Filter Framework says that the silence is caused by a catastrophic bottleneck somewhere in the development path of civilizations. Most civilizations either never get to the technological stage, or get there and quickly destroy themselves. Under this view, the silence is a graveyard, evidence of civilizations that could not survive the transition from primitive to advanced. The policy implication is that we should be working desperately to identify what the filter is, because if it lies ahead of us, we need to find it before it finds us. Every silence we detect might be a warning about our own future. The estivation framework says that the silence is caused by civilizations optimizing for long-term computation efficiency by going dormant until the universe cools. The silence is a waiting room, full of entities that are present but inactive, conserving themselves for a future we cannot imagine. Under this view, the universe is full of sleeping giants, and our broadcasts are the cosmic equivalent of making noise in a library full of people trying to concentrate. The policy implication is ambiguous. It does not say we are in danger, just that we are alone in the active universe for the foreseeable future. The Dark Forest framework says that the silence is caused by the strategic behavior of surviving civilizations that have internalized the logic of cosmic paranoia equilibrium. The silence is not a graveyard or a waiting room. It is a hunting ground in which the survivors are the ones who learn to move quietly. Under this view, the universe is actively structured by the behavior of intelligent agents, and the structure it has arrived at is dangerous for any civilization naive enough to announce its existence. The crucial difference between Dark Forest and the others is that Dark Forest is the only explanation that treats silence as intentional behavior by living, active intelligences. The Great Filter kills civilizations. Estivation suspends them. Dark Forest shapes them, selects for a specific kind of behavior and against another. It is not a passive process. It is a dynamic one, and this distinction matters enormously for how we should interpret our own situation. If the Great Filter is ahead of us, we might destroy ourselves through internal catastrophe regardless of what we broadcast. If estivation is true, broadcasting is at worst impolite. But if Dark Forest is true, broadcasting is not just risky. It is the specific behavior that the entire structure of the universe has been, over billions of years, selecting against. Dark Forest also has an important epistemic advantage over the other explanations. It does not require life to be rare. It does not require civilizations to fail. It does not require any unusual or unpredicted physics. It requires only the same two things that explain every other instance of strategic behavior in the history of life on Earth: competition for limited resources and the capacity to reason about risk. Both of those things are as close to universal as anything in biology. The universe produces intelligence. Intelligence reasons about survival. Reasoning about survival under conditions of resource scarcity and radical uncertainty produces the Dark Forest. The logic is almost embarrassingly clean. The only strange thing about it is how long it took us to take it seriously. Part 15. The Unfalsifiable Trap. Here is where we have to be honest about the limits of what we're discussing, because a theory that explains everything and predicts nothing is not science. It is storytelling. And we owe it to ourselves to look clearly at where the Dark Forest logic stops being a scientific hypothesis and starts being an unfalsifiable philosophical position. The core problem is this. The Great Silence, the absence of detectable signals from other civilizations, is consistent with at least 4 major explanations: rare earth, Great Filter, estivation, and Dark Forest. It is consistent with several smaller explanations as well. A scientist would say that the observation does not discriminate between these hypotheses, which means the observation alone cannot tell us which one is true. Worse, the specific prediction of the Dark Forest theory, that advanced civilizations exist but are deliberately hiding, is almost certainly unfalsifiable. How would you test for the presence of something that is specifically designed to be undetectable? Any failure to detect would be consistent with either the absence of civilizations or the presence of civilizations that are hiding. The theory predicts the same observational outcome as the empty universe theory, which means the two are observationally equivalent and cannot be distinguished by any measurement we can currently make. Philosophers call this the information horizon problem. An observer inside a system cannot always fully characterize the system from within it. We are inside the galaxy. We cannot take an outside view of it. We cannot observe what is happening in all of it simultaneously, nor can we observe the deliberate choices being made by entities that are specifically optimizing for our inability to observe them. This is not a reason to dismiss the Dark Forest theory. It is a reason to hold it with appropriate epistemic humility, as the most coherent explanation we have for the silence, not as a proven fact. The absence of evidence is not evidence of absence, but it is also not proof of presence. We are navigating in genuine darkness here, and the most honest thing we can say is that we do not know. What we can say is this: the Dark Forest theory is consistent with all available evidence. It has a sound logical foundation in game theory and evolutionary biology. It makes qualitative predictions, primarily that detectable signals from other civilizations will be rare, transient, and non-repeating, that are consistent with the observational record of SETI. It requires no special pleading, no exotic physics, no appeal to the improbability of intelligence. And perhaps most importantly, it is the explanation that takes the silence most seriously as information, not as an absence of data, but as data, not as a puzzle waiting to be solved by better instruments, but as a pattern that already contains meaning if we are willing to read it. The uncertainty will not resolve itself. We may never know with confidence why the sky is quiet, but the uncertainty itself, as maddening as it is, forces us to take seriously the possibility that the silence is strategic and to ask whether our own behaviour should change in response to that possibility. Part 16. The Temporal Illusion. There is one more layer of complexity to add before we turn the lens back on ourselves, and it is a simple one, almost too simple, but it reframes everything we have discussed tonight in a way that is quietly devastating. Everything we observe in the universe is old. Not mildly old, not pleasantly vintage in the way that a good bottle of wine is old, but cosmically ancient in a way that the human brain was genuinely not built to process. When you look at the Andromeda galaxy on a clear night, and you can see it with the naked eye if you know where to look, a faint smear of cold light in the constellation Andromeda, the most distant object visible without a telescope, you're not seeing it as it is. You're seeing it as it was 2.5 million years ago. The photons landing on your retina right now left that galaxy when our ancestors were small, bipedal creatures wandering the African savanna, making crude stone tools, with no concept of fire and no language to describe what they saw when they looked up. 2.5 million years of travel, and those photons have only just arrived. The Andromeda galaxy right now, in this actual present moment, might be unrecognizable compared to the image you see. Stars that appear in your sky have already completed their entire life cycles. Stars that have not yet formed in the image you observe may already be billions of years old in present reality. Civilizations, if they exist there, have had 2.5 million years to rise, transform, go dark, be replaced by something else, and leave no trace that the light now reaching your eyes could possibly carry. You're not looking at Andromeda. You're looking at a portrait of Andromeda painted 2.5 million years ago by light that has been travelling ever since. And Andromeda is our neighbour. It is practically next door by cosmological standards. The GHAT survey, the one we discussed earlier that searched over 100,000 galaxies for the infrared signatures of Dyson spheres and found none, was not looking at the universe as it currently exists. It was looking at galaxies as they existed millions, tens of millions, hundreds of millions, and in some cases billions of years ago. The nearest galaxies in the survey were tens of millions of light years away. The light from those galaxies left before multicellular life had appeared on Earth, before animals, before eyes existed anywhere on this planet to see anything. The survey was not measuring whether advanced civilizations exist in the universe. It was measuring whether advanced civilizations existed in those galaxies at a specific moment in the deep past, a moment so remote that our entire evolutionary history, from single-celled organism to the person watching this video, had not yet begun. We found nothing in that data. But nothing in that data tells us nothing about right now. It tells us about then. And then is so long ago that the word then barely carries enough weight to describe it. This is what physicists and philosophers call the light travel time problem, and it has a specific and deeply uncomfortable implication for the Fermi Paradox that does not get discussed nearly enough. The silence we observe may not be present silence. It may be ancient silence. It may be the silence of a universe that was, at the moment the light we are currently receiving was emitted, genuinely quieter than it is today. The civilizations that exist in those galaxies right now, if they exist, may have developed Dyson spheres in the last few million years, well after the light we captured had already left and begun its journey toward us. They may have gone dark in the last few million years for exactly the reasons the dark forest theory predicts. They may have done things we cannot imagine, using physics we have not discovered, in the time between the snapshot and the present. We're not receiving a live feed of the universe. We're receiving an archive, an incomprehensibly old, patchy, incomplete archive of light that left its sources at various points in the deep past and has been travelling toward us ever since. Every telescope ever built is a time machine that only goes backward, and the further you look, the further back you go. There is no instrument we can build that shows us the universe as it is right now. The present state of the cosmos is, by the fundamental rules of physics, permanently inaccessible to us. Under the dark forest framework, this temporal displacement does not weaken the logic of silence, it reinforces it at every level. Consider what it means for civilizations trying to make decisions about each other. You're not just uncertain about another civilization's intentions, you're uncertain about whether what you have detected still exists in any recognizable form. You're uncertain about whether the civilization that sent a particular signal, or failed to send one, is the same civilization that exists at the source of that signal right now. You're making irreversible strategic decisions based on information that is, at minimum, years out of date, and potentially millions of years out of date, about entities that may have changed beyond all recognition in the intervening time. The uncertainty problem, which was already severe enough to produce dark forest logic under normal conditions, becomes essentially total when you factor in light travel time. You're not dealing with a snapshot of your potential adversary from last week, or last year, or last century. You're dealing with a snapshot from before your sun formed. The gap between what you can know and what is actually true about any other civilization is not a gap you can close with better instruments or more patience. It is a gap built into the structure of space-time itself. It is as permanent and unchallengeable as the speed of light. The universe does not have a now. This is one of the genuinely strange conclusions of Einstein's special relativity, and most people hear it and nod politely, and go on treating time as a universal constant that everyone everywhere shares. But it is not. Every point in space experiences time locally. What appears simultaneous to an observer here is not simultaneous to an observer 1,000 light-years away. There is no cosmic clock ticking at the same rate everywhere. There is no master timeline on which all events can be arranged in order. There is only the light that has arrived, carrying its ancient news from wherever it was born, and the enormous darkness of everything that is happening right now in places whose light has not yet reached us, and will not reach us for years, centuries, or millions of years. Right now, in the actual present moment, the one you and I are sharing as you watch this, things are happening in the Milky Way that we cannot see. Stars are going supernova, planets are forming, and perhaps, in some corner of the galaxy whose light is still centuries away from reaching Earth, civilizations are making decisions. Decisions about energy and expansion and visibility and risk. Decisions shaped by the same logic we have been following tonight, or by logic we have not yet imagined. Those decisions are being made right now, in the only present moment that exists, and we have absolutely no access to them. We could be surrounded by a galaxy that has filled up with intelligence in the last million years, after the light we are currently receiving was already on its way to us carrying images of emptiness. We could be in a galaxy that was once full and has since gone dark for exactly the reasons the dark forest theory describes. The silence spreading outward through the spiral arms like a wave of understanding, each civilization going quiet as it worked out what the quiet of its neighbours meant. We could be, against all probability, genuinely alone in a universe where intelligence arose once and has not yet arisen again. The only thing we know with certainty is that we cannot know with certainty, and that acting as though we do, broadcasting our location, our biology, our history, our existence into a cosmos whose present state is permanently hidden from us, is a form of confidence that the universe has never shown any particular interest in rewarding. The temporal illusion does not resolve the Fermi Paradox. Nothing resolves the Fermi Paradox, at least not yet. But it does something perhaps more important. It reminds us that the silence we have measured so carefully, across so many wavelengths and so many years, is not a measurement of the present universe. It is a measurement of the past one, and the present universe, the one that exists right now, all around us, in every direction, at every distance, is something we have never seen, cannot see, and may never fully understand. We are navigating by starlight, and starlight, beautiful as it is always news from somewhere that no longer quite exists. Part 17. Our position in the forest. So where does all of this leave us? Let us think carefully about our actual situation, because it is more specific and more strange than the abstract version of the discussion might suggest. We have spent a lot of time tonight in the realm of theory, game theory, cosmological logic, the cold mathematics of survival under uncertainty. But theory eventually has to land somewhere real, and the place it lands when you follow it all the way down is here, this planet, this civilization, this specific moment in the history of a species that has been making electromagnetic noise for about 90 years without fully understanding what that noise might mean. Somewhere around the year 1930, the electromagnetic signature of human civilization first became detectable from space. Not the deliberate broadcasts, not the Arecibo message, not the carefully composed SETI transmissions, just the ambient radiation of a technological society doing what technological societies do. Radio broadcasts carrying music and news and weather reports. Military radar sweeping coastlines and horizons for threats. The industrial electromagnetic noise of a species learning for the first time to use electricity at scale. None of it was intended as a message to the cosmos. All of it leaked into space anyway, because electromagnetic radiation does not stop at the edge of the atmosphere. It keeps going, at the speed of light, in every direction, forever. That signal has been travelling outward for approximately 90 to 95 years, which means right now, expanding away from our sun like an invisible sphere growing at the fastest speed the universe permits, there is a bubble of human-generated electromagnetic radiation roughly 90 to 95 light-years in radius. Inside that bubble, the electromagnetic environment has been subtly altered by the presence of Earth's technology. Outside it, as far as the universe is concerned, we might as well not exist. 95 light-years sounds like an enormous distance. In everyday terms it is. Light travels about 9.5 trillion kilometers in a year, which means 95 light-years is a distance so large that if you tried to drive it at highway speed, you would need approximately 1 trillion years to complete the journey, which is about 70 times longer than the current age of the universe. So yes, by any human standard, 95 light-years is incomprehensibly far. But here is the context that matters. The Milky Way is 100,000 light-years across. Our detection bubble, the sphere within which our existence is electromagnetically detectable, is 95 light-years in radius. If you shrink the entire Milky Way down to the size of the continental United States, from the Pacific coast of California to the Atlantic coast of Maine, our detection bubble becomes roughly the size of a large shopping mall parking lot. Not the mall, the parking lot. We have announced our presence to an area that represents, by surface area, about 1/10 billionth of our galaxy's disk. We are not broadcasting to the galaxy. We are whispering to our immediate neighbourhood, and most of the neighbourhood cannot hear us yet. But some of it can. Within that 95 light-year radius, there are somewhere between 300 and 500 stellar systems, depending on how you count binary companions and brown dwarfs, and the various objects that occupy the ambiguous boundaries between star and non-star. Alpha Centauri, the nearest star system to our own, sits at 4.2 light-years, close enough that our earliest radio signals, the ones that left Earth in the 1930s, reached it in the 1930s and 40s. Within 10 light-years there are roughly 14 stellar systems, including Barnard's star, the Wolf 359 system, and Sirius, the brightest star in our night sky. Within 50 light-years the number grows to several hundred. Within 100 light-years, several hundred more. Among all of these systems, astronomers have identified a meaningful number of potentially habitable planets, worlds in the habitable zones of their stars, of roughly terrestrial size, not obviously hostile to liquid water on their surfaces. Proxima Centauri b, orbiting the nearest star to our Sun at a distance of only 4.2 light-years, is one of the most discussed candidates. though its habitability is genuinely uncertain, given that Proxima Centauri is a flare star that regularly bombards its planets with radiation. There are others. Some of the nearby Sun-like stars, stars similar enough to our own, that their habitable zones overlap with orbital distances where rocky planets can exist, have candidates worth watching. We do not know if any of these worlds host life. We do not know if any of them host technological civilizations. The honest answer is that we have no idea. But here is the thing about not knowing. Not knowing cuts in both directions. It means we cannot confirm that anyone is out there. It also means we cannot confirm that no one is, and the detection works both ways. Any civilization that exists within 95 light-years of Earth and that possesses radio telescope technology, at least comparable to what we currently have, technology we built within the last century, at a relatively early stage of our development, could detect Earth's electromagnetic signature. They would not necessarily decode our television broadcasts or understand our radar pulses as deliberate communication. The signal is genuinely weak at those distances, smeared across frequencies, buried in noise. But they would see an anomaly, a rocky planet orbiting a sun-like star, emitting electromagnetic radiation in patterns that natural processes do not produce. A world that hums at radio frequencies in ways that stars and gas clouds and cosmic ray interactions simply do not account for. A signal that says, not in any language, but in the universal grammar of physics, something here is using technology. That anomaly has been visible to anyone within range looking in the right direction since approximately the 1950s and 60s, when our signal had travelled far enough to reach the nearest potentially interesting systems with enough strength to be plausibly detectable. We have heard nothing back. Now hold that fact carefully, because it is doing a lot of work depending on which framework you use to interpret it. Under the standard, optimistic interpretation of the Fermi Paradox, the absence of a response from within our detection bubble is simply evidence that no technological civilization exists within 95 light-years of Earth. This is the most parsimonious explanation. It requires the fewest assumptions. It might be correct. The nearest technological civilization might be 500 light-years away, or 5,000, or 50,000. Our little electromagnetic bubble might not have reached anything capable of receiving it yet. We are a small fire in a large forest, and the nearest other fire might be far enough away that our light has simply not arrived. That is a reasonable interpretation. It is also, depending on your state of mind, either comforting or lonely in equal measure. Under the dark forest interpretation, the absence has an entirely different texture. If something within 95 light-years detected our signal, and detected it decades ago, given that the nearest systems have been inside our bubble since the mid-20th century, and if that something is operating under the strategic logic we have been discussing all night, then it would not respond. Responding would require transmitting. Transmitting would reveal its location, and revealing its location, under dark forest logic, is precisely the thing that surviving civilizations have learned not to do. Think about what that information asymmetry looks like from their perspective. They know where we are. We announced our location 90 years ago without meaning to, and we have been updating that announcement continuously ever since, with every radar pulse and radio broadcast and satellite transmission. Our coordinates are not a secret. Our existence is not a secret. Our approximate level of technological development, inferable from the frequency range and character of our emissions, is not a secret. From the perspective of anything within our detection bubble that has adequate instruments, we are an open book. They, on the other hand, are invisible to us. We have no confirmed detection of any technological civilization within 95 light-years. We do not know their location. We do not know their capabilities. We do not know whether they exist at all. The information flows entirely in one direction, from us, outward, into a silence that tells us nothing about what received it. That asymmetry they know, we do not, is precisely the kind of strategic advantage that dark forest logic says a surviving civilization would never voluntarily surrender. Transmitting a response to us would collapse that asymmetry. It would tell us where they are, and whatever uncertainty they have about our intentions, whatever calculation they are running about whether a young, electromagnetic leaking civilization is a future threat or a future resource or simply a curiosity, they would be making that calculation from a position of informational advantage that a response would immediately destroy. So they stay quiet, if they are there, if any of this is real. We have, without choosing it, entered a strategic situation we did not design and do not control. The entry happened in the 1930s, without a meeting, without a debate, without a single human being making a conscious decision that this was the moment to announce our existence to the cosmos. It happened because we built radios, because we built radar, because technology leaks radiation, and radiation travels at the speed of light, and the speed of light does not stop at the heliopause. We are visible. We have been visible for nearly a century. We cannot become invisible. The signal is already out there, already 90 years old, already passing through hundreds of star systems, already absorbed and analysed by whatever instruments exist in the neighbourhood of whatever worlds circle the nearest stars. The horse left the barn when your great-grandparents were young, and no decision we make today changes what was already sent. Whatever judgment is being formed about us, if any judgment is being formed, if anyone is out there to form it, is being shaped by the electromagnetic portrait of a civilization at its noisiest and least self-aware. The radio signature of the 1940s and 50s, the radar of the Cold War, the television broadcasts of a species that had not yet visited its own moon and had no idea this conversation would ever happen. We lit the fire 90 years ago. We did not know it was a fire. We did not know what kind of forest we were lighting it in, or who else might be moving through the trees, or what the rules were about fires. And now, here we are, 90 years later, standing next to the fire we lit, debating whether to light more of them, while the darkness around us stays exactly, perfectly, deliberately quiet. Part 18. Someone may be hearing us right now. This is the part that is hardest to sit with. Not the abstract logic of the dark forest. Not the game theory, not the Drake equation, not the infrared surveys of 100,000 galaxies. Those things are difficult in an intellectual way. They challenge your assumptions. They reframe your expectations. They make you think differently about the night sky. But they are distant. They are theoretical. They are about other civilizations in other places at other times. This part is about right now, about the actual present moment, about what is potentially already in motion. Let us start with the geometry, because the geometry is where the strangeness lives. The signal from Earth is not a perfect sphere expanding uniformly outward from our sun in all directions. That is the simplified version, and like most simplified versions, it is useful but incomplete. The reality is messier and in some ways more interesting. Earth rotates. Our sun moves through the galaxy. Different transmitters on Earth's surface point in different directions at different times. The result is that the electromagnetic portrait of our civilization, as received by any particular point in space, is not a clean omnidirectional broadcast. It is a complex, layered, directionally variable record of a species doing 1,000 different electromagnetic things simultaneously, some of them intentional and many of them not. Military radar installations, for instance, are not omnidirectional. They sweep specific arcs of sky, which means that star systems in the path of those sweeps received unusually strong signals at specific moments, signals that would look very different from the ambient background leakage of our radio broadcasts. The Arecibo message of 1974, the deliberate transmission Frank Drake and Carl Sagan aimed at the globular cluster Messier 13, travelled in a single tight beam in a single direction. Any civilization in that direction received a signal orders of magnitude stronger than the ambient leakage. Other intentional transmissions over the decades have been similarly directed. The electromagnetic portrait of Earth is not one thing. It is many things, and it looks different depending on where in the sky you're receiving it from. This matters because it means the question of who might have detected us and what they might have detected is not a single question with a single answer. It is hundreds of questions, each one dependent on the specific location of the receiver, the specific time of detection, the specific frequencies they were monitoring, and the specific transmitters on Earth that happened to be pointing in their direction at the relevant moment. A civilization in the direction of Tau Ceti, about 12 light-years away, received a different version of Earth than a civilization in the direction of Vega, about 25 light-years away. Both received something. What they made of it is a question we cannot answer. Now here is the thing about the speed of light and the geometry of what follows from it. We do not know, we genuinely, fundamentally, by the laws of physics cannot know, what is happening right now in response to our signals. And the phrase right now is doing enormous work in that sentence, because right now, at interstellar distances, is not a concept that behaves the way our intuition suggests it should. Think about the nearest star system, Alpha Centauri, at 4.2 light-years away. Our earliest detectable radio signals, the ones that began leaking into space in the late 1920s and early 1930s, reached Alpha Centauri somewhere around 1932 to 1935. If there is a technological civilization in that system, and if their instruments were adequate to detect our signal, they have known about us for roughly 90 years. They have been receiving our continuous electromagnetic output ever since. Every decade of our development, the Second World War, the Cold War radar installations, the first television broadcasts, the moon landings, the Internet age and its explosion of wireless communication has arrived at their instruments in sequence, like chapters of a book delivered one at a time, each one 10 years after the last. A civilization 4 light-years away that detected our first signals in the mid-1930s and decided immediately to respond would have sent a signal that arrived at Earth around 1939 or 1940. We were not listening in 1939. We did not have the instruments or the inclination to scan the sky for narrowband radio signals from neighbouring star systems. If that response came and we missed it, we would have no way of knowing. The signal would have passed through our solar system and continued outward, carrying its message into the void beyond us, never received, never read, gone forever at the speed of a light. Maybe they sent something and we missed it. Maybe they are still deciding. Maybe they decided long ago that silence was the answer and have been watching us ever since from behind that silence, updating their assessment with every new decade of our electromagnetic output, never revealing themselves, filing away the data on the noisy young civilization in the outer spiral arm that seems blissfully unaware of what it is doing. We do not know. And the not knowing has a very specific shape. There is a temporal window, bounded on one end by the moment our signals first became detectable, and on the other end by right now, within which any civilization within our detection radius has been making decisions about us. Some of those decisions may already be complete. A civilization 80 light-years away that detected our signals 45 years ago, when those signals first reached them, has had 45 years to deliberate. 45 years is not a long time by civilizational standards, but it is long enough to make a decision. Their decision, whatever it is, may already be encoded in a signal currently travelling toward us at the speed of light. That signal, if it exists, left its source decades ago and is somewhere in the space between us right now, moving at 300,000 kilometers per second through the interstellar medium, carrying information we have no access to and no awareness of. We will not know it exists until it arrives, and we do not know when it will arrive, or if it will arrive, or what it will say. That is the vertigo. That is the thing that is hard to sit with. We are in the middle of a conversation that may already be happening, conducted entirely at the speed of light, and we can only hear our own half of it, the outgoing half. The half that consists of 90 years of radio broadcasts and radar pulses and television signals and deliberate transmissions, all of it moving outward through the galaxy, all of it potentially being received and processed and evaluated by something we cannot see or detect or communicate with in real time. The incoming half, the responses, if any exist, are either already on their way, or have been decided against, or were never sent because no one was there to send them. We cannot tell the difference between those three possibilities from where we sit. They are observationally identical to us right now. Silence looks the same whether it is the silence of an empty universe, the silence of a decision not to respond, or the silence of a response that has not yet arrived. And here is the detail that tends to catch people off guard when they think about it carefully. The civilizations that might be deciding what to do about us are not deciding based on what we are now. They are deciding based on what we were when our signals reached them. A civilization 50 light-years away is currently receiving Earth's electromagnetic output from 50 years ago. 1975. Watergate had just ended. The Vietnam War had just concluded. We had not yet invented the personal computer. The internet did not exist. The Human Genome Project was 15 years in the future. Whatever impression they are forming of us, whatever assessment they are making of our intentions and capabilities and trajectory, it is based on a version of our civilization that the people alive today would barely recognize as their own. We are being judged, if we are being judged, by a portrait of ourselves that we painted 50 or 80 or 90 years ago, at a time when we were noisier and less self-aware and had no idea this conversation would ever be worth having. The version of humanity currently on display to the nearest potentially inhabited star systems is not the version that is sitting here tonight, thinking carefully about the implications of its own visibility. It is the version that was still figuring out television, the version that was running Cold War radar installations around the clock and had not yet visited its own moon, the version that lit the fire without knowing it was a fire. Something might be deciding right now what to do about that version of us. In a star system whose sun is visible from your backyard on a clear night, if you know where to look, close enough that the light reaching your eyes from that star left before you were born, close enough that whatever lives there, if anything lives there, is practically a neighbour by the only scale that matters out here. Whatever decision it reaches will not reach us at the speed of thought. It will not arrive in a dream or a sudden intuition or a feeling that something has changed. It will reach us at the speed of light, as a pattern of electromagnetic radiation arriving at one of our radio telescopes on some ordinary day, indistinguishable from background noise until someone looks at it carefully and realizes that the pattern is too deliberate, too structured, too specific to be natural. Or it will not reach us at all. Because the decision was silence. Because whatever is out there looked at the noisy, young, electromagnetic leaking civilization in the outer arm of the Milky Way and made the same calculation that the dark forest theory predicts every surviving civilization eventually makes. And until the light arrives, or does not arrive, we sit exactly where we have always sat, under the same sky, next to the same fire, broadcasting into the same darkness, waiting, without knowing we are waiting, for an answer to a question we did not know we were asking. Part 19. The Silence Reframed. We began tonight with a simple observation. The sky is too quiet. Not quiet in a way that required sophisticated instruments to measure. Not quiet in a way that only specialists could appreciate. Quiet in a way that becomes more pronounced, more insistent, more structurally strange the more carefully you look at it. Quiet across 100,000 galaxies searched for the thermal signatures of megastructures. Quiet across 62 years of radio and optical SETI, sweeping hundreds of thousands of stars across dozens of frequency ranges, with instruments that have grown more sensitive with every passing decade. Quiet across every channel and methodology and approach our species has been able to bring to bear on the question, from the 85-foot dish at Green Bank in 1960 to the most sophisticated signal processing algorithms running on modern supercomputers. Across all of it, in every direction, at every frequency, we have heard nothing that we can confidently, honestly, unambiguously call a signal from another mind. The traditional response to this observation has been patient optimism. It is a generous and in many ways admirable response. The instruments are not sensitive enough yet. The search has not been long enough. The universe is 13.8 billion years old and incomprehensibly large, and we have been listening seriously for about 60 years with equipment that a sufficiently advanced civilization might consider roughly equivalent to 2 tin cans connected by string. The parameter space of possible signals, frequencies, modulation types, directions, timescales, encoding schemes is so enormous that 60 years of searching represents a genuinely tiny sample. Somewhere out there, under this view, the silence will eventually break. We will hear the voice of something that is not us. The instruments will pick up a pattern that cannot be natural, cannot be interference, cannot be explained away, and in that moment everything we think we know about our place in the cosmos will be transformed beyond recognition. That is a beautiful hope. I want to be clear that I do not think it is wrong. I am not standing here at the end of this conversation prepared to tell you with confidence that we are alone, or that the dark forest is definitely real, or that the interpretation of the silence we have been developing tonight is the correct one. It might not be. The Great Filter might be real, and the silence might be a graveyard of civilizations that could not survive their own technological adolescence. Rare Earth might be real, and the extraordinary concatenation of circumstances that produced complex life on this planet might be so improbable that it has simply not happened anywhere nearby. The universe might be more empty than the optimists predicted, not because the physics of life are unfriendly, but because the specific path from chemistry to consciousness is narrower than we hoped. Any of those things might be true. I hold them all with genuine uncertainty, because genuine uncertainty is the only honest position available to us right now. But I want to offer you a different frame for the silence before we part ways tonight. Not a frame that replaces the others, but one that sits alongside them and asks a different question. Not, what happened to all the civilizations? But, what if the silence itself is a form of communication? What if it is not a puzzle waiting to be solved by a future signal, not evidence of absence waiting to be overturned by better instruments, but a message already sent, already received, requiring only the right interpretive framework to read? A message written not in radio waves or laser pulses, or the mathematical structures we imagine a friendly civilization would use to introduce itself, written in absence, in the deliberate, sustained, consistent maintenance of nothing across every channel we can monitor, by every civilization in the history of this galaxy that survived long enough to understand why the nothing matters. The message is not malevolent. I want to be careful about that, because the dark forest theory can sound like a counsel of despair, a vision of a universe red in tooth and claw, where every intelligence is a predator and existence is a permanent war. That is not quite right. The message does not say the universe is evil. It does not say the other civilizations out there wish us harm or are waiting for an opportunity to eliminate us out of cruelty or aggression. It says something colder and in some ways more unsettling than that. It says the universe is uncertain, and that uncertainty at cosmic scales, across light-year distances and million-year timescales, is functionally indistinguishable from hostility in its consequences. You do not need malice to produce the dark forest. You need only the combination of finite resources, imperfect information, and stakes high enough that the cost of a wrong guess about trust is extinction. Those three ingredients are not exotic. They are the basic conditions of existence for any entity that wants to survive in a competitive universe. The message says that intelligence, wherever it emerges, eventually confronts the same cold calculation. The benefit of being heard might be smaller than the cost of being found. Not definitely smaller, not certainly smaller, but possibly smaller, and possibly smaller is enough, when what you are risking is everything. The civilizations that lasted long enough to leave any trace of their existence in the observable pattern of the cosmos are, under this reading, the ones that looked at that calculation clearly and chose, for reasons they understood better than we currently do, to go silent. Not because they had nothing to say, because they learned, through whatever process of experience or reasoning or terrible example, the price of saying it. The universe may be full. That is the thought I find myself returning to, again and again, when I look at the night sky after sitting with these ideas for a while, full of minds that found each other's silences and read them correctly, full of intelligences scattered across the spiral arms of 100 billion galaxies, each one sitting in its own darkness, maintaining its own quiet, having made the same journey that we are perhaps only beginning to make from noisy, hopeful, broadcasting species to something quieter and more watchful and more aware of the rules of the place it finds itself in. The silence is not emptiness. The silence is the curriculum. It is the lesson that the universe teaches every civilization that lives long enough to learn it, delivered not through any direct communication, but through the simple, patient, irrefutable fact of its own consistency. Every civilization that survived wrote to the ones that came after in the only language that crosses interstellar distances without revealing the location of the sender, the absence of signal, maintained deliberately at tremendous cost, as the only form of communication that does not carry a return address. And we are here, somewhere in the early chapters of that education, still making noise, still hoping someone will answer, still operating under the assumption that visibility is neutral or positive, that the universe rewards the curious and the open and the reaching out, that intelligence recognizes intelligence as kin and responds with fellowship rather than calculation. It is a generous assumption. It is the assumption of a young species that has not yet sat long enough with the alternative to feel its full weight. If the dark forest is real, and I am not telling you it is, only that the logic that produces it is sound and the silence that would confirm it is exactly what we observe, then there are things older than our sun that have watched young civilizations before us arrive at this exact moment. The moment of understanding. The moment when the silence stops being a puzzle and starts being a message. And those ancient, quiet things have watched those young civilizations make a choice. Change or do not change. Go quiet or keep broadcasting. Accept the lesson of the silence, or continue to believe that this particular forest is somehow friendlier than the logic suggests. The ones that changed are not visible to us. They went dark and the darkness absorbed them, and now they are part of the silence that is teaching us. The ones that did not change are not visible to us either, for reasons that the dark forest theory describes in terms we have spent tonight making precise. We do not know which kind we will become. That is not false modesty or dramatic framing, it is the literal truth of our situation. We are a civilization that has been accidentally broadcasting its existence for 90 years, that is only now beginning to think carefully about what that means, that does not yet have consensus on whether the thinking matters or what to do about it if it does. We are in the middle of the story. The ending has not been written. What I find most extraordinary about this entire question, and I have been sitting with it long enough now that the extraordinariness has had time to settle into something quieter and more permanent than initial shock, is not the terror of it, though it is genuinely terrifying if you follow the logic all the way down. It is the loneliness of it, the specific, structural, unavoidable loneliness of the image it produces. Every intelligence in the galaxy, independently, separately, through its own path of experience and reasoning and discovery, arriving at the same conclusion, sitting in the same darkness, looking out at the same quiet sky from the inside of its own small bubble of electromagnetic silence, making the same calculation and staying quiet, not in communication with any of the others, not coordinated, not agreed upon, just separately, individually, inevitably, reaching the same answer that the universe teaches to everything that asks the question long enough and honestly enough to hear the reply. That image of a galaxy full of minds, each one alone in its silence, each one having learned the same lesson through its own isolated experience, none of them able to share that knowledge without violating the very principle the knowledge demands, is one of the loneliest things I have ever tried to hold in my head. A community of solitudes, a fellowship of the isolated, a conversation conducted entirely in absences between parties who will never meet, about a truth they all arrived at separately and can never safely confirm to each other. Tonight, if you can, go outside. Find somewhere the light pollution is thin enough that the sky gives you something of itself. Look up at the Milky Way if it is visible, that river of ancient light that is actually the compressed edge-on view of our galaxy's disk. 200 billion to 400 billion suns reduced by distance to a smear of pale, cold luminescence across the sky. You're looking at a structure so large that light takes 100,000 years to cross it. You're looking at a history so long that our entire civilization, from the first stone tool to this video, represents less than 1/100th of 1% of it. You're looking at a place that has had time, incomprehensible, unimaginable amounts of time, to fill up with things that think. Some of those suns have planets. Some of those planets are warm. Some of that warmth is being used by something that grew from chemistry, the way we grew from chemistry, that asked the same questions we're asking, that looked at the same silence and eventually stopped asking why it was quiet and started understanding what the quiet meant. Something is using that warmth carefully, deliberately, in the way that things that have survived for a very long time learn to be careful and deliberate about everything. And somewhere in that river of light, in that ancient, patient, unreadable cascade of photons that left their sources before our ancestors walked upright, there may be a mind looking back in the direction of our sun. Watching the faint, untidy, electromagnetically noisy glow of a young species that is only now, in these late decades of its first technological century, beginning to understand what it has gotten itself into. Watching with whatever passes for patience in something that has been quiet for longer than our sun has existed, waiting to see what we will do with the understanding if we reach it in time. The silence is not a puzzle, the silence is the answer. It has always been the answer. We just needed to learn how to read it. And the most important question remaining, the one that will be answered not by any telescope or signal processor or mathematical framework, but by the choices we make as a civilization in the decades and centuries ahead, is not whether we will finally hear something in that silence. It is whether, when we understand what the silence is saying, we will be wise enough, humble enough, and clear-eyed enough to listen. The forest is not empty. The forest is full, and every tree in it learned, a very long time ago, not to make a sound.